Imagine a tremendous gathering played by a perpetual number of stars, planets, and moons, all playing together superbly. At any rate, there is one explicit fragment of this ensemble that has shocked space specialists for a seriously significant time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary system, hidden away somewhere deep in the Milky Way. You might be surprised to find that among the gigantic number of galactic objects, there are exoplanets so like Earth, so tantalizingly similar, yet confusing that they might be our planet's divine twin. We plunge into the charming space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is transforming our journey for understanding these divine secrets. Imagine, for a second, your mind venturing across the vastness of our reality, the Milky Way, home to more than a quadrillion exoplanets. That is a number with 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon, we'd have enough to make another landmark on Earth, a Grand Canyon 2.0 that would extend for a huge distance. It is generally surprising that around 20% of these glorious bodies have been designated Earth-like in terms of geology and atmospheric structure. That means there is a 1 in 5 chance of seeing a twin of our planet. And the story doesn't end there. Close to these planets, there could be another quadrillion moons, rough satellites like our moon, trapped in a gravitational dance with their parent planets. If you were to ponder tracking down another body in space that harbors life, or could the universe offers a flood of chances? Now that we've laid out the scale of this unimaginable reality, it's time to introduce the master craftsman prepared to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified primary mirror measuring 6.5 meters, 2.7 times greater than Hubble's, beats even the most advanced optical instruments. Imagine the detail it can separate, even in the smallest blaze of a star billions of light-years away, and then analyze the nuances of orbiting planets. What makes the James Webb Telescope revolutionary isn't simply its seeing power, but also its high-end technology, including advanced sensors and spectrographs. These tools can do considerably more than observe. They can analyze and channel the remarkable light signatures emitted or reflected by celestial objects to decipher their atmospheric conditions, density, and even mass. Acting as a space researcher, the telescope can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope elevates itself from a mere observer to a scientific genius. It's not just an advancement over its predecessor, Hubble, it's more like a quantum leap. If Hubble's revelations stunned you, get ready for a genuine celebration of radiant discoveries. Just as we expanded our gaze across the complex landscape of the universe, it's worth focusing on one specific star in this divine show, Proxima B. Since its discovery in 2016, this baffling planet has stood out like a Shakespearean legend, full of unpredictability and problems astonishing stargazers and anthropologists alike. What's the big deal? First of all, Proxima B is basically in our galactic neighborhood, just 4.2 light-years from Earth. To put it in context, if you could beat the universal speed limit and travel at the speed of light, you'd arrive in just over 4 years, about the time it takes for your favorite TV show to fall into reruns. But let's dive deeper into why this planet matters so much. We're examining a universe that stretches over 93 billion light-years from one end to another. Finding a planet so close and so scientifically promising is like finding a gem in a pile the size of Mount Everest, a gem that potentially holds mysteries about existence itself. In the grand tapestry of the universe, Proxima B is a complex thread offering us significant hints that could reshape how we comprehend habitability and life beyond Earth. It's not just Proxima B's nearness that excites scientists, but also the captivating signs that this planet isn't just Earth-like but potentially Earth 2.0. Proxima B sits comfortably in what space scientists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we start dreaming of visiting Proxima B, we must consider a few of its peculiarities. A single day on this entrancing exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only introduce a new day but unfurl slowly, resisting the arrival of afternoon, and sunsets that linger, creating golden hours photographers long for. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adjust to such patterns of light and dark? Would we need to eat 3 or 4 times as much in a single day? Would we sleep the same way? On this strange world, The basic patterns of life, as we know them, would be simultaneously familiar and frustratingly alien. It's as though nature is giving us a riddle wrapped in a riddle, challenging our understanding of what makes a planet livable. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It's more than just a telescope, it's a complex research lab floating in the vacuum of space. Thanks to its innovative technology, cosmologists can not only observe but also examine planets with instruments that would make a CSI lab look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by distant planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a kind of remote biopsy determining atmospheric pressure, density, and the possible presence of life-essential compounds like water, carbon-based molecules, and oxygen. Space science today is not just cosmology, it's space forensics. We don't sit around waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up these distant worlds. The Webb telescope isn't just an eye in the sky, it's an investigator and scientific detective, all in one. It allows us to turn our hypotheses about alien worlds into testable, confirmable conclusions, changing our understanding of what might exist beyond our blue dot. And just when we thought we had uncovered the most stunning layers of this galactic mystery, the story took an unexpected turn. Like any science fiction thriller, scientists using the James Webb Telescope received something surprising from Proxima B, a signal. A signal so astounding, it spread like wildfire through academia and social media. Named a potential tech signature, it was an electromagnetic discharge so complex and intricately designed that it could indicate the presence of an advanced civilization. And just as suddenly, it vanished, never to be repeated. It left behind not just silence, but a maze of unanswered questions. Was it a random cosmic anomaly, a coded message, or a sign of intelligence? The event cast a shadow of mystery over Proxima B, sparking intense debate and speculation. Was it a passing oddity or part of a much bigger story? This time, it's not just traditional scientists but Harvard researchers who are leading a new wave. They're turning the James Webb Space Telescope into a sort of giant night vision device searching for artificial light sources on distant planets, even in their darkened hemispheres. Imagine detecting the glow of artificial cities, urban clusters illuminated against alien night skies. Could these lights be signs of advanced civilizations? Cities humming with intelligent life. As we continue unraveling the secrets of the universe, the quest for extraterrestrial life evolves. No longer limited to mere speculation about Proxima B, our pursuit expands into the vast, mysterious frontier of deep space. The advances we've made, biomarker detection, spectrographic analysis, infrared imaging, have expanded our ability to explore exoplanets and assess their habitability. A particularly promising area is the search for biosignatures, signs of life such as atmospheric methane or carbon dioxide, which could indicate biological processes. The JWST's capabilities allow it to measure these in exoplanet atmospheres, revealing environments potentially capable of supporting life. Proxima B remains at the forefront of this mission, guiding our inquiry. Even if it doesn't harbor life, it opens the door to new questions and systems worth studying. And while scientists are cautious about drawing conclusions from anomalies like the Proxima B signal, the search for technosignatures such as artificial light could transform our approach to detecting extraterrestrial intelligence. This dynamic exploration is powered by collaboration across astronomy, biology, engineering, and artificial intelligence. As our technology improves, so does our reach, and already, new missions are planned to probe even deeper.